Hi students, in this video let me introduce transcendental and polynomial equations and also how to find the roots of such equations. So let us know the definition of polynomial function. A function f of x is said to be polynomial function of degree n if f of x is a polynomial in x, that is f of x is equal to a naught into x power n plus a1 into x power n minus 1 plus and so on. A naught is not equal to 0 and n is positive integer. For example, x plus 1, x square plus 2x plus 1, x cube minus 1. So these functions are called polynomial functions. If f of x is equal to 0, polynomial is equal to 0 is called polynomial equations. For example, x plus 1 is equal to 0 is a polynomial equation. X cube minus 1 is equal to 0 is a polynomial equation. A function f of x which involves trigonometric function, exponential function, logarithm functions. So such functions are called transcendental function. For example, x plus sin x e power x plus log x e power x plus cos x. So these functions are the transcendental functions. If these functions is equal to 0 are called transcendental equations. A number xi is a root or solution of the equation f of x is equal to 0 if f of z is equal to 0. The number xi is known as root of f of x equal to 0 or 0 of f of x equal to 0, where f of x equal to 0 either polynomial equation or transcendental equations. For example, let f of x equal to x plus 1 is equal to 0. For x equal to minus 1, f of minus 1 is equal to minus 1 plus 1 is 0. Therefore, x equal to minus 1 is a root of the equation x plus 1 is equal to 0. So, or minus 1 is 0 of x plus 1 is equal to 0. So, let us take another example. X plus sin x is equal to 0. For x is equal to 0, 0 plus sin 0 so that is 0. Therefore 0 is a root of the equation x plus sin x is equal to 0. If I take another example, sin x is equal to 0, so this implies when x is equal to n pi, n belongs to the integer, so sin of n pi 0, therefore n pi are the roots of the equation sin x is equal to 0. Now let me plot the graph of the function f of x equal to x plus 1. Let us draw the coordinate system. X-axis, y-axis. At x is equal to 0, f of x is and y is 1. This is 0 comma 1. At x is equal to minus 1 and f of minus 1 is 0. This is minus 1 comma 0. So we can plot the graph of the function f of is equal to x plus 1. Here we can observe x equal to minus 1 is a root of equation x plus 1 is equal to 0. So at the value of x, means at the root x equal to minus 1, always the curve crosses the x-axis. You can observe. From the second example, let us take x plus sin x is equal to 0. Let us draw the curve for x plus sin x equal to 0. We can write like this, it goes like this. So this point, when x is equal to 0, when f of 0 also 0, x is 0 and sin 0 is 0, therefore x plus sin x is equal to 0 when x is equal to 0. So this point 0 comma 0. At the root of the equation, the curve crosses the again x-axis. So let me take another example, that is sin x is equal to 0. So let us plot the graph, the equation like this. We can plot in positive x-axis. Similarly, like this we can write. Note this point x is equal to 0, x is equal to pi, x is equal to 2 pi, minus 2 pi. So f of x is 0. Here 0 comma 0, this is pi comma 0, this is 2 pi comma 0, this is minus pi comma 0, like this it goes. At the root, f of x always crosses the x-axis. So geometrically we know that a root of the equation f of x equal to 0 is a value of x at which the graph of y is equal to f of x crosses the x-axis, crosses the real line. Let f of x is equal to 0 be an equation. Suppose if f of x can be written in the form f of x is equal to x minus xi whole power m into g of x. Here you can observe that x minus xi is a factor m times. X minus xi is multiplying m times. Therefore, xi is a multiple root of multiplicity m. Then the number xi is called multiple roots of f of x equal to 0 of the multiplicity m. Suppose if and g of xi is not equal to 0. Suppose if g of xi is equal to 0, then xi is a multiple root of multiplicity m plus 1. So therefore let us take the condition g of xi is not equal to 0. Suppose if xi is a multiple root of multiplicity m, then f of xi is equal to 0, f dash of xi equal to 0, and so on. M minus 1th derivative of xi also 0, and mth derivative of xi is not equal to 0. So this is the property of when xi is a multiple roots of the equation f of x equal to 0. For example, let f of x is equal to x minus 1 is equal to 0, that is equal to 0. Here you can observe that 1 is the root of the equation, f of 1 is equal to 0. So x minus 1 is a factor 2 times. So therefore 1 is a multiple root of f of x equal to 0 of multiplicity 2. Therefore f of 1 0, f dash of x, let us calculate here, f dash of x equal to 2 times of x minus 1. This implies when f dash of 1 also 0. F double dash of x here, that is equal to 2, but f double dash of 1 is not equal to 0. So understood, if 1 is a multiple root of multiplicity 2, so then f of 1 also 0, f dash of 1 also 0, but f dash of 1 is not equal to 0. Let us take another example with multiplicity 3. For example, f of x is equal to x minus 1 whole cube. Here you can observe that 1 is a multiple roots of multiplicity 3. Therefore f of therefore f of 1 0, f dash of 1 0, f double dash of 1 also 0, but f triple dash of 1 is not equal to 0. Let us check now. F dash of x is equal to here 3 times of x minus 1, f double dash of x is equal to x minus 1 whole square, f double dash of x is equal to 6 times of x minus 1, f triple dash of x is equal to 6. Now let us check when x is equal to 1 for f dash of x, that is 0, f double dash of 1 also 0, but f triple dash of 1 is not equal to 0. That f of x equal to x minus xi whole power m into g of x, where xi is called multiple root of f of x equal to 0. Suppose if m is equal to 1, f of x becomes x minus z into g of x. Then z is called simple root. So you know the difference between multiple root and simple root. So in the case of simple root, obviously f of z is equal to 0, but f dash of z is not equal to 0. To find roots of the equation f of x equal to 0, generally we use two types. One is direct method, one is direct method, nothing but analytical method. Second one is iterative method. The direct method is nothing but analytical method. So this method gives the exact value of the root of the equation f of x equal to 0 in finite number of steps, and also will get all the roots of the equation f of x equal to 0 at the same time. For example, ax plus b is equal to 0. So this implies x is equal to minus b by a, but a is not equal to 0. So x equal to minus b by a is a exact root of the linear equation. And let us take second example, ax square plus bx plus c is equal to 0. So this equation has two roots. We'll get all the roots at a time, and so this direct method gives the exact answers to this equation. So you know the roots of this equation, x is equal to minus b plus or minus square root of b square minus 4ac by 2a. So we'll have two roots at a time, and so these two roots are exact roots of the quadratic equation. So it is understood analytical method gives the exact solutions within a finite number of steps, and also it gives all the roots of the equation f of x equal to 0 at the same time. To find the root of the equation f of x equal to 0, so we have another method. It is an iterative method, nothing but numerical method. So this method gives the approximate value of the root of the equation f of x equal to 0. To find approximate root of f of x equal to 0, we start with the initial roots. Start with initial approximation roots x naught. Maybe one can assume that more than one initial approximations also, such that f of x naught is near to 0. Let us draw in the coordinate system. So x-axis, this is y-axis. So we take a curve here. This is y is equal to f of x. We know that at this point f of xi is equal to 0. So this point is xi comma 0. Therefore xi is a root of this equation f of x equal to 0. So geometrically you can show that at the root of the equation always the graph of the equation crosses the x-axis. So therefore near to xi, let us take an initial point, that is x naught. For x equal to x naught, you can see that f of x naught is this point. Always while assuming the initial value, you take a initial value x naught such that f of x naught close to the 0. We can construct the better approximation root of the equation f of x equal to 0. Let us take x1 here. F of x1 is this point. When compared to x naught, x1 is a better approximation. So keep on constructing the better approximation of the equation f of x equal to 0 such that f of xn approaches to 0. Construct the sequence of numbers x1, x2 and so on xn such that f of xn approaches to 0. Let us take the sequence of numbers here x0, x1, x2 and so on xn. Let us take xn here. When f of xn, this point we can plot f of xn here. As xn approaches to xi, then the number xi will be the limit of the sequence xn. From the figure we observe that the successive approximations x0, x1, x2 and so on xn approaches to the exact root xi. Therefore f of x approaches to the 0. Therefore x0, x1, x2 and so on xn are successive approximations of the root xi. Therefore the process of constructing successive approximations is called iterative method. For example, ax square plus bx plus c is equal to 0. A is not equal to 0. So this can be written as x is equal to minus c plus ax square by b. So this implies xk plus 1 is equal to minus c plus a into xk square by b. B is not equal to 0 here. When k is equal to 0, 1, 2 and so on. And you have to choose the initial value x naught. When k is equal to 0, that is x1 I can find out, that is minus c plus a into x naught square by b. You can find out x2, x3 and xn and so on. Here the sequence xn is equal to 1 to infinity is a sequence converges to the number xi, where xi is the root of equation ax square plus bx plus c is equal to 0. And observe from this example, so this method, iterate method, gives the only one answer at a time. So that is, the xn approaches to the xi. We have only one solution at a time, and moreover it iterates infinite times. It takes infinite number of steps to find the approximate root of the equation f of x equal to 0. As we know that iterative method gives the approximate roots of the equation f of x equal to 0. To find the root of the equation f of x equal to 0, so we need initial approximation, so that is x naught. The question arises how to choose the initial approximations. Let us plot the graph of the function. X-axis, vertical line is y-axis. The curve crosses the x-axis at this point f of x 0. So take a point xi and f of xi is equal to 0. This is the point xi comma 0. So therefore xi is the exact root of the equation f of x is equal to 0. So any value neighborhood of xi is the initial approximation. Let us take x naught is the initial approximation of the root xi. So to find the initial approximation, f of x can be conveniently written in the form f1 of x is equal to f2 of x. Let us take y is equal to f1 of x and y is equal to f2 of x. Intersection of two curves, for example, the curve y is equal to f1 of x and the curve y is equal to f2 of x. Intersection of two curves y is equal to f1 of x and f2 of x is this point. So at which you can define the point xi. So xi is the root of the equation f of x is equal to 0. It means intersection of two curves y is equal to f1 of x and f2 of x gives the root of the equation f of x is equal to 0. Therefore, neighborhood of xi can be taken as initial approximation, that is x naught. For example, f of x is equal to 2x plus 1. We know that f of minus of is equal to 0. Therefore, minus of is a root of equation 2x plus 1 is equal to 0. So let us find out the initial approximation of the root minus of. Let us split the function as x plus 1 is equal to 0. So this implies minus x is equal to x plus 1. So let us take y is equal to minus x, that is f1 of x, and y is equal to x plus 1, so that is f2 of x. Let us draw the graph of the function y is equal to minus x. For y is equal to minus x passing to the origin, this is y is equal to minus x graph. For the second graph, y is equal to x plus 1. So intercept at the point when x equal to 0, this is 1 comma 0. When x equal to minus 1, so this is the point, this is minus 1 comma 0. This is minus 1 comma 0. So intersection of two curves y is equal to minus x and y is equal to x plus 1 is the root of the equation 2x plus 1 is equal to 0. So at this point we can see that here approximately this is a minus half. When x equal to minus half, so that is f of minus half is equal to 0, therefore it is the root of this equation. At x equal to minus half, so these two curves are intersected. So neighborhood of minus half, any value neighborhood of minus half is the x naught. You can choose x naught as a 0, or you can choose x naught as a minus 0.3, or any value neighborhood of minus half, we can take it as initial approximation of the root minus half. So this is how we can choose the initial approximation. We have another method to find the initial approximation to the root. It is based on the intermediate value theorem. So this theorem says that if f of x is continuous function in the interval AB, and f of A into f of B is negative, then the equation f of x equal to 0 has at least one root in the interval AB. So what this theorem says that if f of x is continuous function in the interval AB, and the product f of A and product of f of A and f of B is negative, so then the equation f of x equal to 0 has at least one root in the interval AB. Let us show it in the graphically. So take a curve, y is equal to f of x. So this function is continuous for the interval AB. So this is the first quadrant, all are positive. Here x is negative, y is positive, x and y both negative. Here x is positive, y is negative. We can observe that at x is equal to a, f of a is positive. At x is equal to b, f of b is negative. Therefore, product f of a into f of b is negative. Therefore, the function f of x is equal to 0, the equation f of x is equal to 0 has at least one root between the interval a comma b. We know that, so this point, at this point xi, f of x, f of xi is equal to 0. So xi is the root of this equation f of x is equal to 0. So therefore at least one root will be there in the interval a comma b, provided if product f of a into f of b less than 0. Suppose both f of a and f of b both are positive. Suppose for example our function is like this. If I take, this is a interval ab, if I consider function defined in interval ab, here f of a also positive and even f of b also positive. F of b lies in the first quadrant, so both are positive. Therefore f of a into f of b is positive. So there is no root lies between in this interval. Suppose if you consider here interval a and b, this point f of a is negative, but here f of b also negative. Product f of a into f of b is positive. So you can observe here, so there is no root between a and b, because f of a and f of b is positive. Because where is the root? So root is here. At this point we have a root of the equation f of x equal to 0. Therefore, if there exists a root between the interval ab such that f of a and f of b must be negative. Let us take an example. Suppose f of x is equal to x plus sin x is equal to 0. X plus sin x is equal to 0 is an equation. F of minus pi by 2. F of minus pi by 2 is equal to minus pi by 2 plus sin of minus pi by 2. That is equal to minus pi by 2 minus 1. So this is negative. Now f of pi by 2. F of pi by 2 is equal to pi by 2 plus sin of pi by 2. So that is equal to pi by 2 plus sin pi by 2 is 1. So this is positive. Therefore product f of minus pi by 2 into f of plus pi by 2 is negative. Therefore root of this equation lies in the interval minus pi by 2 comma plus pi by 2. Let us draw the graph of this function equation. X-axis, this is y-axis. So x plus sin x curve is like this. Here again, at x equal to minus pi by 2 and here x equal to, let us take pi by 2. So this point is root of this equation. X plus sin x is equal to 0. So 0 is a root of this equation. When x equal to 0, 0 plus sin 0, that is 0. Therefore 0 is a root of this equation. So you can observe that f of minus pi by 2 is negative in this point. y is negative. Okay, both are negative here. So here both are x and y are positive. So f of minus pi by 2 is negative, f of plus pi by 2 is positive. Therefore root lies between the interval minus pi by 2 to plus pi by 2. What is root of this equation? Root of this equation is 0. At x equal to 0, sin 0 plus 0 is equal to 0. Therefore 0 is a root of this equation. So that root lies between minus pi by 2 to plus pi by 2. So any value neighborhood of 0 will be the initial approximation. Otherwise, we can take either pi by 2 is the initial approximation, or we can take minus pi by 2 will be the initial approximation. So this is a general method to find the initial approximation to the root